بسم الله والحمد لله والصلاة والسلام على محمد رسول الله وعلى آله وصحبه ومن والاه. I will talk about Ktor framework for Kotlin Multiplatform. Ktor is an asynchronous framework used to build different types of applications such as server applications, web applications, and many more, including Kotlin Multiplatform applications. It was developed using Kotlin programming language, which makes it great for us to use in KMP projects. We can send requests to an API on the network and receive data from the API as well. I will demonstrate post and get operations in a simple to-do app. I will not focus a lot on the UI design. The purpose of the app will be to show successful post and get operations. The app will have a single screen, two buttons at the top of the screen for the post and get network calls, an alert dialog that will display the post state message, a loading indicator, a lazy column to display the data that we get from the API, and a list item for each to-do. We need to get the project files from kmp.jetbrains.com. We choose a name and the project ID for our project and select the platforms we want to work with, and then we download the project files. We open the project in Android Studio and switch to the project view. I added the dependencies to the project, so let's take a look at them. We will use Kotlin coroutines, we will use Coin for dependency injection, and we will use Ktor framework. The Ktor libraries consist of Client Core, OKHTTP for Android and desktop, and Darwin for iOS. We will add Kotlin X serialization library, and the last library from Ktor is Content Negotiation. We scroll down to the plugins section and we add Kotlin X serialization plugin. We get it from JetBrains and it will have the same version of the Kotlin version of the project. We open the build.gradle file in the common main. In the plugins block, we add the Kotlin X serialization plugin. We scroll down to source sets. In the Android main dependencies, we add the coin dependencies for Android. We add the coroutines for Android. We add the Ktor OKHTTP client for Android as well. In the common main dependencies, we add the coin dependencies, and we add the coroutine core, Ktor core, Kotlin X serialization JSON, and content negotiation dependencies. In the desktop main dependencies block, we add the coroutine swing and Ktor OKHTTP client for desktop. We create iOS main dependencies block and add Ktor Darwin client to it. Finally, we change to the Material3 library. We will follow the MVVM design pattern. The project will have data, DI, UI, and util packages. We need to install a plugin to Android Studio. It's called JSON to Kotlin data class. It's a convenient plugin which allows us to create data classes from JSON files. In Android Studio, to the top right, we click the gear icon and select Plugins. In the Marketplace tab, we search for JSON to Kotlin data class plugin and install it. We'll use a fake API called JSON placeholder. I will provide the link in the description. It is important to read the API's documentation to learn about the API's requirements. The API allows us to test various operations. We will create a to-do using the post command, and we will get a list of to-dos using the get command. If we click on the to-dos link, we get the API response in the browser. The API response shows a list of to-dos. We can copy one of the to-dos from the browser. A single to-do is represented in JSON between two curly brackets. Now we can use it to create the Kotlin data class. We go back to Android Studio. In the data package, we create a remote data package. In the remote data package, we create a model package. We right-click on the model package. We select New Kotlin data class from JSON. We paste the JSON data into the editor. choose a name for the class. In the advanced option, we choose if we want the variable to be nullable or not. We'll keep it non-nullable. For the annotation tab, we choose Kotlin serialization if it's not already selected. Click OK and click Generate. We'll have the data class created. In the DI package, we create a file, call it network module. In the network module, we'll create a singleton of the HTTP client. We can pass an engine to the HTTP client function. However, when we configure the HTTP client without an engine, the client will choose an engine automatically depending on the dependency that we added in the build.gradle file. In the HTTP client, we install the content negotiation plugin and we add the JSON content type. Ignore unknown keys will ignore values or parameters that are not valid or not added to the data class. Network calls are prone to errors. We need a way to handle network responses in a safe way. One way is to create a generic class for error handling. In the utility package, we create a network response class. It will be a sealed class of type T. T is a generic type and can be any class. We'll have two parameters, a data parameter of type T and an error parameter of type string. In the sealed class, we will have a success class, which will have a data parameter and return the network response class along with the data parameter. We'll have a failure class, which will return the error message. And the third class will be a loading class, which will return an empty response. In the remote data package, we create repository package. In the repository package, we create the to-do repository interface. We create a function for posting a to-do. The post function will return a Kotlin flow of a string network response. We create another function to get the to-dos that will return a flow of to-dos list network response. We create the implementation of the to-do repository interface and inject the Ktor client in the parameter. For the post to-do function, we open a flow. We open a try-catch block. In the try body, we emit a loading network response to indicate the beginning of the network call. We build the HTTP request using the prepare post function. The difference between prepare post and post functions is the post function will execute the request immediately, while the prepare post does not until we call the execute command. We add the API URL, we use the header to set the request header, and the parameter function to pass the parameters to the API. Normally, we would request the values from the user to pass it to this function, but I will hard-code the values here. We add 2 seconds to simulate network delay. Then we execute the request. We emit the response, and in the catch block, we catch and emit the failure message. For the getToDo function, we do similar work. We don't need to pass any parameters to the get requests, only the API URL. In the execute block, we emit the response body. In the catch block, we emit the exception in a failure class. We go to the DI package and create a shared module. In the shared module, we create the repository singleton. Now we move on to creating the view model. In the UI package, we create a shared view model. We inject the repository into the view model's constructor. We create a private variable. We call it post state. It will be a mutable state flow. And we create a public post state that will return the private post state as a state flow. We create another state flow for the to-dos list. we create post to do function in the view model, and we use the view model scope to collect the data from the post to do function from the repository and update the private post state value. We use the same process to create another function to get the to-dos list. We open the shared module and create the view model singleton in the shared module. In the UI package, we create a home screen composable. We inject the view model into the home screen. We collect the post state in the to-do list. We create a Boolean variable to show an alert box that will display the post state. And we create a launched effect to show the alert box only when the post state is successful or failure. We create an if statement to show the alert dialog and set the buttons to dismiss the alert box and the post state value to the text of the alert box. We create the post button. In the onClick action of the post button, we invoke the post to do function from the view model. We'll create a linear progress bar for the post button that will show only when the post state is loading. We create the get button. In the onClick action, we invoke the get to dos function from the view model. We check the value of the to-dos list. On failure, we create a text with a failure message. On loading, we create a loading indicator. And on success, we create a lazy column to display the to-dos list. On null, we keep it empty. We add the home screen to the app composable. To run the Android app, we set up the application class and add the modules to the start coin function. We register the app in the manifest file and run the application. We post a to-do. We get the to-do list. Everything seems to be working great. To run the desktop application, we add the start coin function to the main function and run the application from the Gradle task executor. We test the application. The app is working great. For iOS, we need to create the initcoin function and add it to the iOS app Swift file. We don't need to run Xcode for that. We go to iOS app directory, open the iOS app file, and add the code to it. We run the application, test the application. Everything is working great. This was a brief introduction to Ktor. There are many other functionalities to it. I hope that you were able to benefit from the video. If you have any ideas or remarks, please share them in the comments. Finally, سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.